Hello students, in this video lesson we will be continuing with exercise 7.1. I'll be solving two questions from this exercise and at the end some homework questions which are given in the form of MCQ, and I want you to do that in your geometry notebook. So let us begin with question number 5 from exercise 7.1. Now in this diagram, it is mentioned that L is the angle bisector of A. Now since L is the angle bisector of A, I've indicated here with a red mark. That shows that angle BAQ is congruent to angle BAP. It is also mentioned that BP and BQ are perpendicular to the arms of the angle and it is perpendicular, so a 90-degree sign has been put. This is what you need to prove. Okay, so students, I want you to copy down this question in your geometry notebook along with the diagram. So let us start with what is given. So mention this, that L is the bisector of angle A and therefore these two angles will be congruent. Now it is not necessary that in here you have to number it as 1. You could leave this, you just mention angle PAB equal to angle QAB, that is more than enough. Also, if you just make a statement that L is a bisector of angle A, that is also fine. Okay. Now next step, BP and BQ are perpendiculars from B. You could write this under given. It is not necessary to copy down this. I have written down this here and have numbered it as 2. This is another way of representing given. Now this is what you need to prove, that the two triangles are congruent, and prove BP is equal to BQ. So students, let us begin with the proof. Now the proof of this. Look at the two triangles. You have to prove these two triangles congruent by the test of congruency. What test of congruency will you use here? Look for the indications. One angle congruent to this angle, each is 90. This angle in red and this angle in red, they are congruent to each other because it is already given that L is the bisector of angle A. Then you notice that this AB is a common side for both the triangles. So you have angle, angle, side. So that is the test of congruency, angle, angle, side. Students, you will start off by writing the name of the two triangles and take care that all the elements of triangle APB will be written below that, and the elements of triangle AQB you have to mention it below. Therefore, the two triangles congruent by AAS congruence rule, and therefore BP is equal to BQ because corresponding parts of congruent triangles. Now, these two triangles, could you prove them congruent by RHS congruence rule? Not in the beginning, because for RHS congruence rule, you need one of the perpendicular side congruent. Now here, no doubt AB is the hypotenuse, and this hypotenuse is common for this triangle as well as the triangle below. But the other perpendicular side is not shown congruent, since no indication is given for this and this perpendicular side. Neither any indication is given for this and this perpendicular side. You cannot prove them congruent in the beginning by RHS congruence rule. So you have to apply angle angle side congruence rule for this diagram. Okay. Later you will realize that once the two triangles are congruent, all the remaining parts become congruent. That means BP will be congruent to BQ, like how we have mentioned out here. Also, AQ will be congruent to AP, right? Because they are the corresponding parts of congruent triangles. And then the triangle becomes congruent by various tests of congruency. But just looking at the indications, now you can prove them congruent only by angle angle side congruence rule. Let us look at question number 6 from exercise 7.1, which is also a very important question. Question number 6. In this diagram, they have mentioned AC is equal to AE, which is given by this indication AC equal to AE, AB equal to AD, AB equal to AD by a single line, and angle BAD, that is this angle, is congruent to angle EAC, that is this angle. Now what is it that you need to prove? You need to prove that BC is equal to DE. Okay, so this is what is given. Mention that out. All that is given out here, I have just copied it back again out here. So what is it that you need to prove? You need to prove BC equal to DE. Let us look at the proof of this question. Now, the clue out here is we will take triangle BAC and triangle DAE at the end. That is our objective, to prove these two triangles congruent, because ultimately they have asked you to prove BC congruent to DE. So in order to prove BC congruent to DE, these two triangles you need to take. So before that, let us write down what all is given. It is mentioned that BAD, that is this angle, is congruent to angle CAE. What I'm doing out here is I am going to add DAC on both the sides. So BAD plus DAC will be equal to CAE plus DAC. Mention the reason. Why is it that I have added DAC on both the sides? Because only if I add DAC angle on both the sides will I get BAC and I will get DAE. So this step is very important, adding angle DAC on both the sides. So after adding, what do you get? You get BAC equal to DAE. This number it as statement 1. This is a very important statement. Okay. Now, take the two triangles. In triangle BAC and triangle DAE, let us write down what all is congruent in that. Now, what I'm doing here is I'm separating the triangles so that you could understand it better. So now you know we are taking triangle BAC and triangle DAE. One line, here one line, this angle congruent to this angle. This is represented by two lines. Here also I have represented by two lines. So now mention what all is given. BA equal to DA. Why is BA equal to DA? It is given. So write that down. These two angles we have just proved congruent. So from 1, that is angle BAC congruent to angle DAE from the statement, and AC, which is given by two lines out here, will be congruent to AE, same indication. Therefore, the two triangles now are congruent by which test? You have them congruent by side angle side. So next step. Therefore, the two triangles are congruent by SAS congruence rule. If the two triangles are congruent by SAS congruence rule, then we have, therefore BC, okay, is congruent to, BC will be congruent to DE. So BC congruent to DE. CPCT, they are the corresponding parts of congruent triangles, and that is what we needed to prove. Students, please make a note of this, and this is a very, very important question. Okay, let us move on to some homework questions. It's in the form of MCQs. Which of the following is not a criterion for congruence of triangles? I want you to write down the answer to this. You know the test of congruency. There are 5 tests of congruency. So find out which is not applicable in this. Now here they have given you the sides which are congruent. What you could do is, in the rough, jot down these two triangles that you get on the basis of these sides and see which is the correct statement. Question number 3. If triangle ABC is congruent to triangle PQR, then which of the following is not true? All you have to do is look at the one-to-one correspondence and you will get the answer. Okay. Now you know that if the two triangles are congruent, all the sides, the corresponding sides and the corresponding angles will be congruent. So look for the proper correspondence in this. And the last question, which is true? A triangle can have two right angles. A triangle can have two obtuse angles. A triangle can have two acute angles. And an exterior angle of a triangle is less than either of the interior opposite angles. We've already done this in the previous video lessons. So I want you to solve these 4 MCQ questions, okay, in your geometry notebook. So students, we end this video lesson out here. In the next video lesson, we will be doing 2 theorems from this chapter, that is the isosceles triangle theorem and the converse of isosceles triangle theorem. Until then, goodbye and take care.